kind of going to do today's lesson in a backwards order because I care more about the second thing than I care about the first thing. So we're going to jump to the second thing, and then we're going to circle back. So on your paper, you have a question about George. We're going to skip that, and then we'll discuss that maybe out in the family or maybe not till tomorrow. It depends on how long our next activity takes. So the other activity that we have today deals with toys. So anyone want to read that little paragraph there about our situation with toys? Zach, you want to read? So if you needed.
Okay. If you need to predict how far a car, train, or plane had gone, it would be helpful to know something about how fast it was going and how long it had been moving. You will work with your team to investigate the relationship between distance, speed, or rate at time in the following experiments. And time in the following experiments.
So distance, rate, and time determine a lot of things. Like who's ever flown on a plane anywhere? I hadn't till I was 18. Who's ever had their plane be delayed? Yeah, giant pain in the butt, right? Distance, rate, and time have a lot to do with that. Now, that's why I kind of shied away from flying for a while. Like, if I had my license, I was like, I'm going to drive. So I've driven to Maine, I've driven to Florida, I've driven, like, way too many places because I don't really love trusting, like, you know, somebody else to make all the plans. So, here is how our teamwork is going to go. You don't know who you're on a team with yet, and neither do I, so just listen. You're going to appoint a timer, a toy starter, and a measure. /marker / you will only have 3 people on your team. So figure out your team roles. The toy starter is going to start the toy. As the front of the toy reaches the starting line, which you're going to grab a meter stick. Like, so if you go back to our first slide here, look at when we go to teamwork in the family room. You're going to want a Chromebook to be used as a timer, a meter stick, any other mathy stuff, and one of our cars up front here. They are lettered on the backs. Violet. Sure, yeah. So whatever way, you got a stopwatch. So this, hey, why? Stop moving. Listen to directions. This is really what's going to help you, and you can make your data table either on a piece of graph paper or if you really want, on this paper, there is some space that you could probably fit a data table over here or maybe fit your data table up top. Like, you can use the extra space on this paper if you want to. Now, notice when you go to look at making your graph, the scaling of time has already been chosen for you. The scaling for distance has not. And notice that their scale is in centimeters, and the questions that I'm going to start to ask you are in meters. So we need to remember our relationship between meters and centimeters. So we could make a little note here in case we've forgotten. 1 meter equals how many centimeters? Anybody? 100, right? Just like century. So 1 meter equals 100 centimeters. So you kind of maybe probably want your graph to go to at least 8. Because our little racetrack is 8.1 meters long. Now let me explain what I mean by our little racetrack. You are not racing against each other. You do not care who has the fastest car. It does not matter who has the fastest car. Do not whine or complain about whose car is faster than yours. Yes, I've done this before. So, you're racing against accuracy. What do we mean by that? You're going to go out there with a meter stick and a car and collect as much data as you want to. Then you're going to use that data to predict the time it would take to travel 1, 3, 5, and 8.1 meters. And other ones if you want. And conversely, the distance you could travel in, I don't know, 10 seconds, 7 seconds, what about like 2.3 seconds? By the end of this, you should probably have 2 equations that relate distance based off time and time based off distance. The question mark here will not be the same here versus here, although they will be related, like very related. And if you can't figure out how they're related, that's okay. We'll all talk about it together. So, essentially, what this might look like as your team gets together is now, these cars don't really take long to accelerate. Like Colin was saying, he's got his RC club. But if you start your car behind the meter stick, your timer could start timing right when it crosses 0. And your timer could stop timing right when it crosses. You don't have to start your car at 0. You can start it before 0. Start, stop, and like you just collect that. Now, if you don't trust that a single run was accurate, what can you do to try to hone in that accuracy, Noah? Do multiple runs and calculate an average. Questions about what we're doing? All right, time for teams, which means I'm going to stop the video. So sorry that you're stuck at home, but there is no way to keep this video going as we go to the family room. So that is all you get for today. Sorry, Soph. Everyone say bye, Soph.
Bye.